Today we are going to talk about SR flip-flop. So this is an SR flip-flop using NAND gate. We all know that the IC for the 2-input NAND gate is IC7400. This is the circuit diagram of SR flip-flop with a clock. This is a 2-input NAND gate. First of all, S and R are the input, and then this clock is also connected. We will see the output from Q and Q bar. This is the truth table for an SR flip-flop. When the clock is 0 and there is any value for S and R, we will get the last value which is already stored in the flip-flop. So the remarks I have written last value. Whenever we are giving a clock pulse, means the clock is 1 and S input is 0, R input is 0, then the output we are getting is Qn, means the last value which is already stored in the flip-flop. Now I am giving the clock 1 and the S input is 0 and R input is 1. So this will give 0 output, which means reset. Now I am giving clock input as 1, S input as 1, R input as 0. So this will give the output as 1 and we will call this as set value. Now I am giving the clock input as 1, S input as 1, R input as 1. So I will get the Q output 1, Q bar output means the complement also 1. So this stage is not possible. That's why this is called forbidden step. Okay. So we are implementing this circuit diagram on this breadboard. This is an IC 7400 for NAND. According to the pin diagram, this circuit I have made. In the pin 1, I have given as the S input. Number 5, I have given as R input, and number 2, I have given as clock. We are seeing the output as 8 and 11, which I have given over here. So here we have to first ground the pin number 7. So I am grounding it over here. This is the ground line. This is the ground line, and pin number 14 is given to plus 5 volt. So I am giving it over here. This is pin number 14. Okay, so I have given it in the positive 5 volt and pin number 7 is always in the ground. Okay, and I will see the output from 8 and 11. 8 is the Q and 11 is the Q bar, means the complement. Okay, so here I have given the 5 volt power supply. The 5 volt power supply line is this, and this is the ground line. So the first input which I am giving is clock 0, S 0 and R also 0. So I will check the output Q. This is the Q output and it's coming as 0.14 and Q bar is coming as 4.89. It means the last value. The next input is clock 0, S 5 volt. So I am giving the S input as 5 and R in the 0, which is already given. So let's check the output. So my Q is coming as 0.13 and my last value, my Q bar is coming as 4.89, means the same last value. Okay, so my next input will be clock 5 volt, is already given in the 5 and R as 0. Okay, so my output is coming as 4.73 Q value. And Q bar is coming as 0.12. It means set. So my next input is clock 0, S 0 and R 5 volt. So I am giving the clock as 0, S as 0 and R as 5 volt. So my output will be, let's see, so it's coming as 4.73 and Q bar is coming as 0.11, means the last value. Okay, so now I will give the next input. Clock will be 5, it's already given, S in the 0 and R. Okay, so clock will be in the 5 and S will be in the 0. Okay, so S is 0, R is 5. So my Q output will be, it's coming 0.11 and Q bar is coming as 4.73. And this is reset. Now I will give the clock 0, S in the 5 volt and R in the 5 volt. So my output is coming as 0.11 and Q bar is coming 4.73. Means no change or the last value. Now my clock will be in the 5 volt, S will be in the 5 volt and R will also be in the 5 volt. So let's check the output. Okay, so Q is coming as 1, means 4.89 and Q bar is coming 4.89, means this is the forbidden value. since both q and q bar are coming the same, the complement and the output, that's why we are telling it as forbidden value.